All right. Find the center and radius of x squared at y squared at 8x, take 2y at 8 equals 0. To do so, we need to rearrange this such that the x terms are together, the y terms are together, and then to complete the square of the x terms, and then complete the square of the y terms, and then put it in the standard form that an equations that the circle is for its equation, which is x minus a all squared plus y minus b all squared equals r squared. So rearranging, we have x squared at 8x plus y squared take 2y plus 8 equals 0. And then completing the square for the x terms and y terms in one sweep, we have x at 4 all squared take 16 plus y take 1 all squared take 1 plus 8 equals 0. Bringing the constants together, so bringing minus 16, minus 1 and plus 8 together, we end up with minus 9, and we move that to the right hand side, and so we have x plus 4 all squared plus y take 1 all squared equals 3 squared. So the center of this circle is 4, negative 1, and the radius is 3. And that's finding the center and radius of the circle given by the equation x squared at y squared at 8x take 2y at 8 equals 0. Next. Hello. Next, how many times does the line x equals 3 meet the circle x squared at y squared equals 9? Alright, so we set x equal to 3 in the second equation. So we have 3 squared at y squared equals 9, so 9 at y squared equals 9, so y squared equals 0. And the only answer to that is that y is equal to 0. So it meets it exactly once at 3, 0. That answers the question, how many times does the line x equals 3 meet the circle x squared at y squared equals 9? We'll try again. Find the equation of the tangent to the circle x squared at y squared equals 20 at the point 2, 4. Alright, let's do it. Okay, So x squared add y squared equals 20 is a circle centered upon the origin. And the gradient of the radius connecting the origin to the point 2, 4 is 2. So the gradient of the tangent will be -1/2. So thus far, the equation is y equals -1/2 plus c. And then we have to use the point 2, 4. And therefore c is 5. So the equation is y equals -1/2 x plus 5. And that's the equation of the tangent to the circle x squared add y squared equals 20 at the point 2, 4. Hello. A chord of a circle has a midpoint M. What angle does the line connecting the center of the circle make with M? 90 degrees. All right. Chapter 7. Simplify. X squared add 5x add 6 all over x squared take 9. So factorize the numerator into x add 3 times x take 2. And then factorize the denominator into x add 3 times x take 3. Cancel x add 3 on the top and bottom. And then we get x add 2 over x take 3. And that simplifies x squared add 5x add 6 over x squared take 9. Well, let me try again. Find the remainder when x cubed add 2x squared take 5 is divided by x take 1. Alright, so that requires the remainder theorem, which I've actually completely forgotten. So I'm going to have to do it the long way. Okay. So x cubed divided by x is x squared. So to be clear, I'm getting the quotient. Alright. So we have x squared on top. then 3x, and then 3, and then 2. So I think it's 2. I can't be sure. Okay, so I need to have a reminder about how this works. Okay. Given that x plus 3 is a factor of x cubed plus ax plus 6, find a. All right. So if we substitute in -3, that should return 0. The cube of -3 is -27. Then minus 3a. Then plus 6. So minus 3a minus 21 equals 0. So a should be -7. And that's answering the question if x add 3 is a factor of x cubed plus ax plus 6, find a. Prove or disprove that n squared plus n is even for every integer n. So what we do is we factor out n, turning n squared add n into n times n add 1. And then if n is even, then n plus 1 is odd. So their product is even. And if n is odd, then n add 1 is even. So their product is even. And that covers both cases. So it's always even. Give a counterexample to the claim that x squared is greater than x for all real values of x. The counterexample is 0, because 0 squared is not greater than 0. write down the full row of Pascal's triangle that begins with 1 and 5. That would be 1, 5, 10, 10, 5, 1. Evaluate 8, choose 3. 8, choose 3. So to evaluate n, choose r, we can use the formula n factorial over n minus r factorial multiplied by r factorial. So in this case, it would be 8 factorial over 5 factorial multiplied by 3 factorial, which is 8 times 7 times 6 over 3 times 2 times 1, which is 8 times 7, which is 56. And that's 8, choose 3. Find the coefficient of x squared in the expansion 3 at x all to the power of 4. Alright, that would be 6 times 3 squared times x squared, which is 54x squared. So that's the coefficient of x squared in the expansion 3 plus x to the power of 4. Find the coefficient of x cubed in the expansion 1 take 2x to the 5. Alright, that would be 5, choose 3, multiplied by the cube of negative 2x. 5, choose 3 is 10. The cube of negative 2x is negative 8x cubed. So it should be negative 80. That should be the coefficient of x cubed in the expansion 1 take 2x to the 5. Find the first two terms of the expansion 1 plus x all to the power of 10 to estimate the value of 1.002 all to the power of 10. Okay, the very first term is 1. And the next term is 10 multiplied by x. And therefore, substituting x for 0.002, it should be 1.02. Approximately. Okay, chapter 9. A triangle has sides 4 and 6, with the angle between them being 120 degrees. Find the third side. We can use the cosine rule, which states a squared equals b squared plus c squared minus 2bc cosine of a. So call the third side a. So a squared equals 4 squared plus 6 squared minus 2 times 4 times 6 times the cosine of 120 degrees. The cosine of 120 degrees is the same as the negative of the cosine of 60 degrees. So negative a half. And therefore the right side becomes 16 plus 36 take 20, 16 plus 36 plus 12. (16 plus 36 plus 12 is 64, and the square root of that is 8. And visually that makes sense. So if the triangle has a pair of sides of length 4 and 6 and the angle between them is 120 degrees, then the third side should be 8. In a triangle, angle A is 45 degrees. Angle B is 30 degrees. And side B is 5. So find an expression for side A in exact form. Okay, so use the sine rule, which states A over sine A equals B over sine B, which equals C over sine C. So this means that 5 over sine 30 equals A over sine 45. And 5 over sine 30 is 10. And 10 has to be multiplied by sine of 45, giving us 5 root 2. And that's for the triangle, where angle A is 45 degrees, angle B is 30 degrees, side B is of length 5, and side A is the side that we have to find. A triangle has sides of length 10 and 6, and area 15. So find the sine of the included angle. So we can use the area formula, which states that the area of a triangle is half times A times B times the sine of the angle between them. Gonna do it again. Wait. Okay. If a triangle has sides of length 10 and 6 and area 15, find the sine of the angle included. So we're going to use the area formula, which states that the area of a triangle is half times A times B times the sine of the angle between them. So half of 10 times 6 times the sine of the angle between them is equal to 15. So the sine of the angle between them is a half. So the angle between them must be 30 degrees. And that's for a triangle where the sides are of length 10 and 6 and the area is 15, and we have to find the sine of the angle between them. So the actual answer is a half, I guess, but the angle in question is 30 degrees. A triangle has sides of length 2, 2, and 2. Find the size of the largest angle in the triangle. So this is an equilateral triangle, and therefore the largest angle is the only angle, and that's of size 60 degrees. Hello. State the minimum value of the graph y equals cosine of x, and find the minimum positive value of x at which it occurs. The minimum value is -1, and it occurs at 180 degrees, or pi radians. The graph y equals sine of x is translated 30 degrees to the right. State its new equation. Its new equation is y equals sine, open brackets, x minus 30 degrees. And that's when you translate the graph y equals sine of x 30 degrees to the right. Okay, chapter 10. Find the exact value of cosine of 120 degrees. So that would be negative a half. That's the exact value of cosine of negative 100 of cosine 120 degrees. State the exact value of sine of 45 degrees. That's root 2 over 2. Or approximately 0.707. Simplify sine squared x over 1 minus sine squared x. So we're going to use the identity sine squared x plus cos squared x equals 1. To rewrite the expression as sine squared x over cos squared x. Then use the identity that tan x is sine x over cos x. So it becomes tan squared x. Yeah, so tan squared x is a simplification of the expression sine squared x over 1 minus sine squared x. Solve tan x equals 1 for x between 0 and 360 degrees inclusive. The answer to that is 45 degrees and 225 degrees. That's solving tan of x equals 1 for x ranging from 0 to 360 degrees inclusive. Solve sine of x over 2 equals root 3 over 2 for x between 0 and 360 degrees inclusive. Now, dividing the argument by 2 stretches the graph horizontally by a factor of 2. So we just get one camel hump, so to speak. And So we need to only think about where does root 3 over 2 occur. So ordinarily it occurs at 60 degrees and 120 degrees. But now we double both. So it will occur at 120 degrees and 240 degrees. And that's solving sine of x over 2 equals root 3 over 2 for x between 0 and 360 degrees inclusive. Solve 2 cos squared x plus cos x minus 1 equals 0 for x between 0 and 180 degrees inclusive. Let cos x equal y, then it becomes 2y squared plus y, take 1 equals 0. And then we factorize that quadratic. To get 2y take 1 times y add 1, 2y take 1 times y add 1. Now for the first factor, cos x equals a half. And if cos x is equal to a half, then between 0 and 180 degrees, x would have to equal 60 degrees. And for the second factor, we have that cos x is equal to -1. And if it's between 0 and 180 degrees inclusive, then x would have to be 180 degrees to satisfy that. So I believe it's 60 degrees and 180 degrees. For 2 cos squared x plus cos x, take 1 equals 0, where x is between 0 and 180 degrees inclusive. Okay, next. If a is equal to 5a is equal to 5i minus j, find 3a. Okay. So 3 times vector a will be 15i minus 3j. Find the magnitude of the vector I plus j in exact form. We simply apply the Pythagorean theorem to the magnitudes of the components. And therefore, the magnitude of that vector, I plus j, will be root 2. If point P has position vector 2i plus 7j, and point Q has position vector, darn it, if point P has position vector 2i plus 7j, and point Q has position vector 5i plus j, find the direction vector Q to P. In other words, how do you get from point Q to point P? Minus 3i plus 6j. So that's if point P has position vector 2i plus 7j, and point Q has position vector 5i plus j, and we're trying to find the direction vector Q to P. If point A has position vector 2i, and point B has position vector 6i plus 8j, find the position vector of the midpoint of the direction vector A to B. Alright, so the direction vector should be 4i plus 8j, and then the position vector of that midpoint should be 2i plus 4j. Determine whether or not the vectors 4i plus 6j and 6i plus 9j are parallel. So recall that vector A and vector B are parallel if and only if there exists a non-zero lambda such that vector A is lambda times vector B. And this is clearly the case for these vectors, as the latter vector is 1.5 times longer than the former vector. So lambda is equal to 1.5, so yes.